Hello, everybody. Welcome. Thank you for joining us today. You are part of the 100 people worldwide who have registered to view this webcast powered by Yole Development and System Plus Consulting, dedicated to Inkjet Printhead industry. My name is Faisal El-Kamasi, and I am a global sales support and coordinator for Yole Development. Before we get started with the webcast, I would like to give some information regarding the logistics. You have the possibility during all the webcasts to submit questions. In order to do so, you simply have to use the box at the bottom of the screen labeled Ask a Question. We will answer as many questions today as time permits, and for the remaining question, we will make a following up via email within a week. You will receive an email after the webcast within, let's say, 24 hours with a link to the recorded session. Let's start the webcast with Jerome Mouley. Jerome is a senior technology and market analyst and business developer for inkjet and biomems within Yole Development. Jerome, please, the floor is yours.
Thank you very much, Faisal. So good morning, good afternoon, depending where you are in the world. So my name is Jerome Mouley, and again, so I'm a senior market analyst at Yole Development on the Inkjet Printhead activity. Today it's my pleasure to present you this webcast. My part is called the key event, create a new momentum in the inkjet printed industry. And I would like to give you an overview of this industry and what is changing in this industry at the moment. So inkjet printed is a quite mature market, but we still see some momentum in this industry created by very interesting applications today that are driving the technology and the growth of the market in certain area. So first of all, what I would like to present on my first slide is to give you the big picture, the overview and history of the inkjet printheads and the inkjet printheads market with the technology related. So this inkjet printed industry is made of successive milestones that coming from the development of the piezo and thermal inkjet printhead is going to some development hybrid MEMS printed mainly, where some semiconductor technologies were used to create the ejection process, and combined with nozzle plates that were made of different material like nickel, for example, or some alloys. The market associated was mainly professional with printers for administration, for example, or in companies. The second or third milestones, if we consider the development phase as the first milestone, is the MEMS and full photolithography processes that made a big momentum in this area, in this sector, due to the impact of the MEMS technology to create inkjet printheads. So this major milestone impacted the consumer market. So it was an opportunity to reach this market and to go to graphics, posters, and to find higher resolution. But anyway, the industrial market in parallel continued to increase in terms of technology and advanced technologies, and the new milestones or area we are at the moment is combining the MEMS technologies, but also the more conventional one with the single pass printheads, with recirculation printheads that allow the possibility to reach commercial and industrial market. So this is an overview of the inkjet history. As a new and other definition, I would like also to make to do a reminder of the different techniques that we are using in inkjet technologies and what we are covering also at Yole development. So the technologies or the ejection principle are or continuous or drop on demand. We are focusing more on the drop on demand because it's where the number of players is the larger. And for the drop on demand, we can separate it in two main actuation technologies that are thermal for one and piezoelectric on the other one. Those two different ejection principles are mainly segmenting the players in two, and this is what I would like to show here in this area. So again, it's a mature market with a limited number of players. The leaders are still the same that you probably know in thermal for the drop-on-demand ejection. So like HP, like Canon, Funai after the acquisition of Lexmark, but also Memjet, that is an increasing player or a player increasing in terms of market share in this sector. And we will discuss about real fast print technology later on. In the Piezo, Epson, Fujifilm, Dymatics, Xaar, Brother, or Konica Minolta are main players. It's where you have the most important number of players in this piezoelectric area. In the continuous market, it's mainly Kodak that is the leader in this area. And based on the technology, we have the conventional printheads. So what we name the conventional printheads are the printheads based on bulk PZT. So it's the piezo ceramic that is processed so to get the actuation. So the you can see again the players I mentioned just before, but we have also the MEMS printed players, and this industry is a little bit different because it means that you need to have some semiconductor capabilities to manufacture MEMS printheads, and this is something that that is also synonym to huge investment and some critical knowledge to manufacture or thermal on one hand or thin film piezo ejection devices. So here we can have IDM, so the companies that are manufacturing their own printheads, but also we would like to mention the foundries that are also helping in this area to manufacture the MEMS part of the printheads or the full printheads. Just to mention, in the foundry activity, the companies like ST Microelectronic, the companies like ROM, for example, Silex, TSMC, depending with sometimes one capability in thin film or one in thermal or both for ST Microelectronics. And also new players that we have recently known in this field, like Robert Bosch, that is also a new foundry that has capabilities for inkjet printed manufacturing. So the application market now. So the inkjet printed, we have divided this in three main segments. The first segment is the consumer and office, where we have more razor blade type of business model. So the inkjet printers are very low cost, and the consumable are doing the business here. The graphics and signage, where you have mainly the large and wide format applications, and the industrial, commercial and industrial applications, where you can segment these commercial and industrial applications in document printing, textile, label and packaging, ceramic decor, 3D and functional printing. So this is something that is properly divided and explained in our report. So this is also where you have the equipment above, just below, the image, and you can find the price, the printer price range there. So the equipment could come from a few $10,000 to several $1 million, depending on the application. And to combine this information from application and technology, this is a representation we have now on where you can find which type of technology and which type of printed. So this representation is showing the resolution and the drop volume. So this in the gray area, you can find the consumer part, where the thin film Piezo and the MEMS printed could have an interest because of the volume generated. It's more the consumer and office printing applications. In the green area, it's where you need to have higher resolution. And it's another interesting capability of the MEMS technologies is to go to very small size of nozzles, but also to increase the resolution. And with this, you can reach all the graphics area, poster, and also label and packaging, depending also the application. So this is the green area for this, with a lot of thin film Piezo and some thermal printed. And in the yellow one, it's more on the lower volumes and also lower resolution, but where we require more droplet volumes, and here we are on the industrial application, where the bulk Piezo is more the domain of this type of printed. So the bulk Piezo that eject with more powerful ejection, more volumes. And here, so related to the three major market that I mentioned, I would like to show you the results we get from our investigation on the inkjet printed market. So this printed market has a global forecast that is growing at 4% compound annual growth rate. So this market is expected to reach $2.7 billion. So it's the inkjet printed market again. And coming from 2.09 or 2.1 billion market in 2018. If we look into more details about this market, so you can see that the consumer market has a slight decrease. this decrease is just after a small rebound we have seen in 2017 and 18 mainly due to HP revenues that increased slightly. This is partially because of the loyalty program, customer loyalty program, that had an impact on the revenues, but on the midterm, we have the forecast. We forecast that this market is continuing to decrease due mainly to digitization, the use of smartphone, tablets. That is for sure an impact for now the past years. Graphic printing is still at 2.4% increase in revenue, so it's a continuous growth on this application. But I would like to highlight the increase in the industrial and commercial market, where the opportunities are growing faster. We are at the level of 10% increase. So if we still have revenues increasing in some area like the label and packaging printing with more than 17% increase, on the other hand, we have some markets that are now that have a certain level of maturity and also slightly decreasing, like ceramic market with -3%, and also some area where the inkjet printheads are really could have a big impact, like in the functional printing application that I will also mention later. This is a representation here, the forecast, so you can see the different bubbles that show the increase of the industrial market here. About the players, so the players have a global presence on the main continents. They have their headquarters. A lot of companies are based in Japan mainly, but they have also some offices and R&D activity and even some production in Europe or in US, and they are closer to the customers, so to get all the information from the needs. If we look at the market share, so the four first companies are representing about 45% of the market. It's HP Inc., followed also by Epson and Canon that are very close together, and Fujifilm Dymatics. So that is the first industrial companies closer to the top three that are mainly serving the consumer market and the graphics printing. About the key events, because the presentation is also based on the key events. It's a mature market again, so we have a number of new products. But in terms of structuration of the industry, the number of merger or acquisition or events are really limited. But anyway, we can just highlight some very interesting and important event, like Panasonic that was, and the asset of Panasonic Printhead that was acquired by Konica Minolta in 2018. So reinforcing Konica Minolta access to MEMS thin film Piezo capabilities. The announcement of a new player in the area of inkjet printhead, so real fast print technology, a Chinese company that just announced that they are ready to produce thermal inkjet printheads. Epson, that has completed and announced that they have completed the factory with a huge investment in terms of for the factory, for the buildings, the new building and the new factory, the new lines, to increase the PrecisionCore printhead, so that will replace also their former technology. I would like also to just highlight some other C-Link and Saitena news. So in the biodispensing, because as you know, the report this year has a focus on the biodispensing and not only the inkjet printed, but what is happening in the bio application. And to just make you informed about these key events, I would like just to illustrate this. The strategy, what we see in this market, is a clear strategy. We are at the moment in the increase and growth of textile, industrial application like label and packaging, that are the current opportunities, business opportunities for inkjet printheads. But we would like also to mention that the printed manufacturers are looking in the future, in the midterm or long-term strategy. And the strategy is to go from the graphic printing to applied printing. So the idea is really to use the original way or the original mission of an inkjet printed to go to a tool to manufacture, to be really a tool to manufacture objects or to texturize surface or to be part of bio applications. And just to illustrate the different milestones also of the major players, it's something that started first from graphic to commercial in the past, with HP acquiring Cytex to go to commercial printing. Canon that also acquire OC, the Dutch company that access document printing and also large formats, and get some capabilities in the Piezo printed applications. But now we are going a step forward to growth opportunities in the industrial industrial market. Again, HP that made the transition to 3D printing, even if it's not properly a 3D inkjet printing. It's a power bed technology, but using their printheads to dispense the fusion agent from the printhead. The Konica Minolta acquisition of Panasonic, knowing that Konica Minolta is one of the company involved in the functional printing applications, like, for example, looking at OLED display, lighting, and so really involved in this market. So they would like also to take opportunity to get Panasonic patent and also capabilities in terms of MEMS technologies and their development. Ricoh and Funai that are now doing the transition to the bio application market, mainly because some consumer or office printing where they are involved are not generating the same growth as in the past, and now they are looking at market that could leverage their market, their business. So this is something that I would like to share with you about this applied printing. And this is one of the roadmap we have established on this functional printing to show you that today we have also this roadmap related to the applications of display market, of PCB, flex or printed and flexible electronics, where some growth are possible for inkjet printheads. This is also for the biodispensing, so just a scope to show that inkjet printheads are also used for the bioprinting, but several competing technologies are also in the place. It could create some opportunities, and here are some benchmark of the techniques we have done. So just also to show you that inkjet printed could be used there, but that dispensing is much more than only inkjet printed. So for example, inkjet printed could have a very interesting application for high throughput screening for pharma, also for liquid handling, what Funai is doing at the moment with Funai Fluidics. For the bioprinting, so Rico is involved in this area. However, extrusion dispensing technique is one of the main technology now. The what I mentioned about Cellink before is about so the technique to bioprint some organs. So Cellink is one of the company with a very interesting activity now. They would like to reach this market of more than $800 million for bioprinting, and they have a growth through merger and acquisition at the moment to reach this market. So regarding the technology trends today, I will not go into detail about that because you will have the next presentation with more detail about the technology, but it's just to mention that Epson with the new factory will increase its Epson PrecisionCore technology with a thin film piezo. You can see on the right side that it's what they named the blade, and this is an interesting way to increase and to have scalable printheads that could be used in different application using the blade as the single element, and that you can combine, that the MEMS technology could allow in terms of precision and reliability. So this is one thing very important for Epson, and we are now looking this technology and the increase of the production to make sure that or to see how this market will go. What will be also the business model of Epson and the impact on the market with this printed that is really decreasing the price with this technology. Just one word about real fast print technology. So this Chinese company, at the moment we know that this company is part of the Anoki group, that is a chemical company. They mentioned that they are ready now to produce the first inkjet printed for thermal ejection, and they have also a piezo printed that is also ready. At the moment, we would like also to follow this company. So we have the same scenario with Memjet a few years ago, but it was on the single pass printed. We don't know any disruptive technology now, but it's something that we would like to follow. And for the main advanced in the technology. So again, for the inkjet printheads, the single pass printhead, and also due to the MEMS technology, is one of the major advance for the past years. At the moment, we would like to mention that so Epson is combining the printheads to do the single pass on label printers, but also for office printing now. Xaar is so on the way to release the 5601 MEMS printhead with the module, the S shape, so that could be also combined for application with high throughput. So the idea is really to use it as a high throughput. And another really interesting thing is the inks recirculation. It's also showing the interest of the printed makers, the printed manufacturers, to go to industrial printing applications, because this is a way to avoid the major issue of printhead, that is clogging when you are using functional inks. And this is also present. This presents the ink recirculation printheads, where you have not only the recirculation inside the printhead, but also in the nozzle. So this avoids the clogging effect and also the sedimentation effect in the printhead. It allows the use of conductive inks with particles, for example, in OLED, well, not only OLED, but mainly for PCB or printed electronics applications. And we are talking a lot about the piezo printed here, but also the thermal printed, like the HP latest latex R2000 printed, is based on ink recirculation. The Canon printed for the office printing is also based on this ink recirculation technology. And for the use of white ink, it's a real interest to avoid the clogging and to avoid the maintenance time and cost for the customers. So this is what I would like to present you today. It's really just a part of what we have mentioned in our report. And just for the key messages, I would like to mention that so the inkjet printed is a mature market, but still with key events happening. They will reach, we forecast a market of $2.6 billion with about 4% growth. With an increase in the industrial market. Those key events are really on the new factory, the new players, and some acquisitions in this market that we will follow for the coming months. The medium-term strategy for most of the players are now to go to applied printing, and this strategy is linked to some technology trends, some new technology trends, still the MEMS technology shift, but also some advanced in bulk piezo, recirculation inks, and single pass printing that are still strong interest of the printed maker at the moment. So thank you for your attention, and do not hesitate if you have any questions. We will answer you as soon as possible.
Thank you very much, Jerome, for your relevant presentation. Once again, do not hesitate to ask questions using the Q&A button for the Q&A session at the end of the webcast. We will now continue with Sylvain Halero, Project Manager at System Plus Consulting. Sylvain, please.
Okay, hey everyone, I'm Sylvain Halero, cost engineer at System Plus Consulting. I'm in charge of Inkjet, Microfluidic, on PCT, and MEMS. And I'm working on the different inkjet on printed since 9 years. And no. Okay. I don't know if you know System Plus Consulting. Your specialty is reverse costing analysis, where you you take a product, here Inkjet component, and you open the printhead, the inkjet, you perform physical and chemical analysis, like cross section, you have a microscopic, electronic microscopy, you can make a physical analysis of the material. You can measure all the dimension of the thickness, all the character, and you can characterize all the material, all the mechanical part and electronic part of the system. And with all this information on this system, you arrive to recreate the manufacturing process of the component. For this, you have your laboratory, and you, with research on documentation, you add more information and more data for your your analysis. And with all these components, you have integrated in your developed in internal different software to calculate the cost of the electronic component. You have begun with integrated circuit, but now you have since more 10 years power component, MEMS component, LEDs, advanced packaging, and electronics board, for example. After, with the physical analysis of the component, you recreate the manufacturing process, and you enter this process in your tools, and with combining the economical parameter like the equipment, the capacity of the equipment, and the etching rate, for example, and the process, you recreate the manufacturing cost of the component. You perform this for the silicon level, but after for all the operation for the backend and for the system with the electronic board, and sometimes with the plastic part. In this presentation, I will present you three inkjet die, as the thermal inkjet die from HP for the last technology, the HDNE, the high definition inkjet die. The new Epson MicroTFP MEMS inkjet die you can find in the PrecisionCore inkjet component, and the new MEMS inkjet die from Xaar. For each inkjet die, you can add a slide focus on the microfluidic part, focus on the actuator, the thermal actuator, or the PCT actuator, and after a slide on the inkjet die cost. And you perform a comparison between the three inkjet die. System Plus Consulting already performed reverse costing of different printhead. We have a bulk capacity inkjet printhead, like here Toshiba CA4 in ceramic and piezoelectric bulk material. You have the color wave 600 from OC. And you have, for example, here the printhead from Kyocera with this printed in laminated steel layer, and piezoelectric actuator into bulk ceramic. You have already performed the analysis of three PCT thin film inkjet, the new MEMS inkjet die technology from Fujifilm with Samba inkjet die, the Epson for the PrecisionCore, and the Xaar printed. And we have also analyzed some thermal inkjet component from HP, Canon, for example, some example of sharing color specialized on the refueling cartridge for inkjet printer. The three inkjet die you have present in this webcast, they are the HP, the new HP 746 HDNA inkjet die, and there you can find this this inkjet die in the new generation of this inkjet Z9 on the latex printer. It's a professional printer. You have already a part on the Epson PrecisionCore. You can find here. It's small, but you can find it's the inkjet die. It's a MicroTFP. Sorry for the error. And this inkjet die can be combined to, for example, to have 4 inkjet die to create for the office printer, for example, or you can create a blade to perform full larger printing. There are different possibilities to assemble this inkjet die to different type of printer, from the office or consumer printer up to the professional printer. And the last, it's a Xaar 1201 printed. It's a piezoelectric thin film, a MEMS die. Xaar don't produce printer, but only the inkjet and printed part of the printer, and this partner that manufacture the printer. For here you have some picture from the Microfluidic of the HP HDNA printed. Here you have in a plastic part from the printed, and you can see that only on top you have the inkjet die in silicone, and between the plastic and the silicone die you have the ceramic carrier. The ceramic carrier has the advantage to increase the lifetime of the printed because it's more easy to assemble inkjet die in silicone with the ceramic carrier, and ceramic carrier is increase the strength of the assembly. It's very interesting for this printed is the transfer of the ink between the tank in the bottom of the cartridge and the top with the nozzle is through the silicone. The ink crosses the silicone thanks to the channel etched by laser and retouching. It's a specific technology developed by HP. And on the top you can see on the right of the slide you can see with the arrows the way of the ink, and you can see the nozzle manufactured in the specific polymer material created on the top of the silicone component. And you can see just under the nozzle there are the heater, and you can see after. On the right top picture you can see the nozzle with the circle. Here is the nozzle. You can see there are 2 different nozzle size, because this printed as is the new technology of HP, the dual drop weight that allow to have different size of the drop you between I think 2 or 3 picoliter and 10 picoliter per drop, and you can select if you want a little drop or a big drop. It's the first time that thermal inkjet die can have dual drop weight. For the microfluidic for Epson PrecisionCore, it's different. You can see here it's printed with a 4 under the bezel there are 4 inkjet die in the MEMS technology. You can see here on the bottom side two open for the ink. In the cross section of the ink printed, you can see that the ink circulates in the plastic part assembled together, and they are going up to the silicone, and after they go to the nozzle. Other interesting thing for the Epson component, you can see on there a connection by a flex between the PCB and the inkjet die, and on the flex there are the driver IC. For Epson, there are each inkjet die can produce one color. But for the Xaar microfluidics, they are different because for each printed, you can print up to four colors. And you can see here the way for the ink, for the 4 colors of the ink, and you have some part of the printed is in plastic, and the active area it's in silicone. You can see here with the inkjet die, but for the Xaar, the nozzle plate with they perform the hole for the nozzle are in steel. For the HP printed, the actuator is thermal. You can see here the heater used to heat the ink and create a bubble of vapor and eject the ink across the nozzle. It's not very simple because you need to have heating at very localized, and here you can see that the heating is created by a very specific layer, very thin, and it's complex because for each time you heat the ink, you create to generate a shock, and you need to protect your circuit. Use electronic close to the circuit, and the heater from the mechanical effect. For this, they use a very specific layer called cavitation protection layer. That is very specific to the thermal inkjet component. Other specificity, it's some very specific shape for the for example, for here, they create a specific etching to create a soft, soft slope to optimize the vapor action on the ink and increase the ink displacement. Other parameters very interesting for the thermal inkjet die from HP or Canon or other companies. They are generally there you have on the inkjet die the heater, but equally the CMOS component, CMOS transistor, and generally DMOS transistor to create the driver function. For the MEMS piezoelectric inkjet die, the driver is not directly in the MEMS, but in the another component, and there generally the MEMS is connected by a flex. For the dielectric actuator for the Epson inkjet die, you can see on the left top left picture the way for the ink. You can see the yellow arrow, and up the top the nozzle, and you have on the bottom the membrane with the actuator in PZT. And when the PZT actuator is activated, that generates a bend. The membrane is bent, and the ink is pushed toward the nozzle. The PZT actuator, it's probably manufactured by the sol gel solution with a spin coating deposition, and you estimate that there deposits this thickness of 1.5 micrometer in probably in 5 spin coating step. But it's not just the unique characteristic of this printhead. The PZT is not the same. The main parameter for the inkjet. They are always to share the movement of the ink and create a channel for the ink, the nozzle. You can see here for this they use not one silicon substrate wafer, but for the Epson inkjet die, we have 4 wafer of silicon that need to create the inkjet die. The different wafers are bonded together with and assembled by adhesive, organic adhesive. And for each wafer, you have very specific operation to create the cavity. For example, with a diarrhea etching, or for this specific inkjet, you have anisotropic etching, and that gives very specific design, and for create one channel for per nozzle. On the right, and for the optical picture, you can see the top of the plate with the actuator, with you have the different electrode and the PZT. For the Xaar print inkjet die, it's more easy because there are only 2 wafer, not 4 like for Epson, but they are not silicon nozzle plate, but the nozzle plate, because the nozzle plate is in steel, and you can see here the membrane with the piezo actuator, always in PZT, but here the thickness of the PZT is more important, is more 2 micrometers, and the process to deposit this inkjet is more complex because there are not 5 layers but 8 or 10 layers of PZT to have to create the actuator. Like for Epson, the different silicon parts are assembled by adhesive, organic adhesive. You can see on the right side a channel with a piezo actuator in the other side of the component. For give an example of the calculation for the cost of the printhead, here it's for the HP printhead. You have it's a very large printhead with area of more 100 square millimeters, and very high definition with 2400 dpi per colors. Each printhead can print 2 colors with 1 colors per channel. The printhead is manufactured by ST Microelectronics in Singapore. It's for this specific printhead in the HP. It's a low volume because it's only it's a new generation and only for the professional application. But the process is very close of the of the printhead you can find in all the office or consumer printer, and the production is very in large volume. And to manufacture this component, you need only 1 silicon wafers. For the Epson, you estimate that the production is performed by Epson in Japan. It's a high volume of production because you can find this the same inkjet die in a consumer and up to industrial product. And to produce 1 printhead, you need to have 4 silicon wafers. And each printhead is optimized for print 1 colors with 600 dpi per colors. And the printhead is at the area of 262 square millimeters. And here you have the repartition of the breakdown of the cost for the inkjet die and the cost of $7.6. For the Xaar inkjet die manufactured by Hirooka in Japan, here you have a very low volume of production, probably under 2,100 today. That can explain the larger, the expensive cost for this inkjet. And there are also 2 silicon wafers to manufacture the component more, and you need add the nozzle plate in steel to finish the component. You are here the number of nozzle and the area. It's a very large die. Here it's a little comparison between the 3 inkjet die, and here you have the cost per for each nozzle. It's a comparison with the nozzle cost. You can see that the new MEMS inkjet die is today more expensive than the old, not the old, but the thermal inkjet die. Other conclusion you can that Jerome already talked. It's you can see for the evolution of the HP printhead. HP are continue with this thermal inkjet die. They are increase their definition of their inkjet. With today you can have 2,400 dpi. That is the new HD technology for HP. But there are always new technology for HP. They add the dual drop rate technology. It's new for HP and for thermal inkjet die. And there are new technology added for this generation of a product from HP is the recirculation for the white ink that, for example, already in the latex printer. Epson has now sent in the market their MEMS inkjet die with a definition of 600 dpi, and Xaar with a definition between 300 and 600 dpi. But in more, there are the possibility to have up to 8 gray level for their inkjet die. And with this, Xaar say that with this 8 gray levels, they can have a definition of 1400 dpi per. Thank you for your attention. It's fine.
Thank you, Sylvain, for this interesting presentation. Wow, there was so to say about this inkjet printhead industry. So maybe we have to conclude. Maybe we have a Q&A session, maybe with 2 quick questions as we run out of time, and we will follow up with the other question. We will following by email. So I've got one question. Maybe Sylvain, that will be for you. So what are the main cost drivers for piezo inkjet technology?
Today, for the piezo inkjet die, the main cost is for the inkjet die. It's a very large die, and today they are manufactured on the 6-inch wafer because Epson and Hirooka have used their old foundry in 6-inch and optimized the process of PCT actuator on this foundry. But when you have a small wafer on a large die, the number of die per wafer is very low, and this increases the manufacturing cost for the die. And after the other, I think for the other criteria, mainly for Hirooka and Xaar, it's probably the low volume of production. There are some specific equipment to process the PCT on the electrode, like specific equipment for spin coating or deposition of a plating or other. And it's the depreciation of this equipment on the low volume of production increase the cost of manufacturing.
Okay, thank you, Sylvain. Maybe one last question. That will be for you, Jerome. What are the technologies used for thin film PZT, and is there any trends for the technology used?
Okay, thank you. It's a good question. It's quite difficult to answer what is good technology. So today what we know is that we have 2 major deposition process for that, for the thin film PZTs, that is sol gel and sputtering. So we still have different players that are using the different technologies. What we see in terms of trend at the moment is that sputtering seems to be one of the choice for the new printheads now, and many foundries are going to sputtering now, probably because this type of tool is most well known in the semiconductor environment and in a clean room compared to sol gel. Anyway, it's still an expensive equipment. However, what we heard is that the deposition process, when well controlled, is quite good. But again, we still have both technologies on the market at the moment.
Thank you very much, Jerome. So we will answer the other question, sorry for that, by email. So the webcast is ending. So within the next 24 hours, you will receive an email that will include the recorded session. Please feel free to share the presentation with who will benefit from the free information that has been presented, and find all our analyses and reports on our websites imicronews.com. Thank you for joining us today. Thank you, Jerome. Thank you, Sylvain. Do not hesitate to contact us if you have additional questions. You can find your appropriate contact on the last slides of the presentation. Have a good day. Bye-bye.